In this video, we'll be discussing the law of sines. The law of sines is a way to use trigonometry to be able to figure out missing sides and angles in oblique triangles. So by the end of this video, we're going to be able to use this idea right here, which is the law of sines. By the end of the video, we're going to be able to use the law of sines to find missing sides and missing angles when we're looking at a triangle. So here's an idea of an oblique triangle. Oblique triangle is one that's not a right triangle. And in all triangles, we've got 6 pieces of information. We've got 3 angles and 3 sides. The angles we name with capital letters, A, B, and C. And we always name the sides based on the angle it's across from. For example, here's angle A, this angle right here. And across from angle A, this side we're going to call lowercase a. So we always are able to determine the side and the angle that it's across from. Here's angle B. Across from angle B is side B. So we use a capital letter for our angles and a lowercase letter for our sides. Now what the law of sines is the law of sines is an idea that happens in all triangles. And the idea is that we can set up a ratio. A ratio is just some fraction or decimal that happens in all triangles. And what the ratio says is it actually happens quite interesting. The ratio is the idea of if we compare a side and an angle. So any side and any angle. What the law of sines says is that ratio in that pair is the same in all of them. So we're going to set up a ratio. The side A divided by the sine of angle A. This is our ratio. And what the law of sines says is if we set up that ratio for all of our side angle pairs, here's angle B and side B, setting up the ratio B, side B, divided by the sine of capital B, angle B. And if we did that for our third pair, angle C and side C, setting up our ratio C divided by the sine of angle C. What the law of sines says is that ratio is equal to each other for all 3 side angle pairs. This is the law of sines. The law of sines is just the idea that in every triangle, the side and the angle's sine, the angle across from its sine, is equal for all 3 of those angle side pairs. Now, since these are fractions and these are just equations, this is just really a couple different equations there, what we can also do is we can also think of the ratios in the reciprocal form. We can think of this as reciprocal being the sine of our angle divided by the sine could be equal to the sine of angle B divided by side B, or equal to the sine of angle C divided by side C. This is an alternate version. It does not matter how you set it up. They're the exact same things. So this is the law of sines. The law of sines is saying that the ratio between a side and the sine of the angle it's across from is equal for all 3 side angle pairs. So how are we going to use this? The way we're going to use this is we're going to use the law of sines to apply when we're looking at some information. Notice we said there were 6 pieces of information, 3 sides and 3 angles. In this example, we're given 3 of those pieces of information, which means we're missing 3 pieces of information. We're given angle A, angle C, and side C. So that means we're missing angle B, capital B, which we need to find, side A, which we need to find, and side B, which we also need to find. So since this is geometric and using trigonometry with these triangles, when in doubt, we're going to sketch this out. And what I want to be able to do is I want to be able to look at a triangle and see these things happening. Now notice this triangle I drew doesn't have necessarily a 24.3-degree angle or a 54.6-degree angle. It doesn't need to have those. This is just a sketch, an idea so that we can help organize ourselves. Later on, we might want to get more specific, but we just want something to help us organize. So I'm going to label my angles. Here's angle A, angle B, angle C. Again, the order of that doesn't matter. And the reason why we're using this is because I want to put the information that was given to us. The information that was given to us was angle A. We know that angle A is 24.3 degrees. We know angle C was 54.6 degrees. And we know that side C, across from angle C, was 2.68 units. Doesn't matter what units we're talking about. So the things that we don't know, and I like to label this just so I remember what we can look for, is we don't know angle B. We don't know this angle here. We don't know side B. So if we don't know things, I'm just going to leave it as a variable. And we don't know angle A. Excuse me, side A. So this is the piece that we don't know. So notice the reason we sketch this triangle is because it helps us visualize what do we have and what pieces of information do we need. So if we recall the law of sines, now those of you that are English people, listen to the way I say this. This is going to be very similar to something that you'll see all the time in standardized tests, and grad school requires you guys to do these, and they're called analogies. Listen to how I'm going to say the law of sines and what I write this down. What the law of sines says is that side A is to the sine of angle A, just as side B is to the sine of angle B, just as side C is to the sine of angle C. So that's one way that we can think of the law of sines. The law of sines is nothing more than an analogy. Those things are equivalent to each other, those ratios. So all I'm going to do is I'm going to go back in and I'm going to plug in the pieces of information that we know. And what we're going to then do is we're going to be able to use the other things. We know angle A. So I'm going to put, instead of A, I'm going to put 24.3 degrees. We know angle C. So I'm going to put here the sine of C. Instead of C, I'm going to put 54.6 degrees. And we know side C, 2.68. The things that we don't know, I'm going to leave as things that we don't know. We don't know what little a is. We don't know side A. We don't know side B. And we don't know angle B. Now, we're going to learn something in the next video called the law of cosines. We're going to have to be able to figure out and distinguish when do I use the law of sines, when do I use the law of cosines. And the way we're going to be able to figure that out is when something like this happens. If we're able to find that ratio, meaning we have the law of sine, we have a sine of an angle and the actual value, meaning looking here, we know the angle's degree and we know the side. If we have that piece of information, what we're going to be able to do is we're going to use the law of sines. And here's what we're going to do. Because we're able to figure out that actual ratio there, we can put that in our calculator and get that number. What we're able to do is we're able to look at something like this. Notice, if I were to look at these two pieces of information, there's only one variable that we would still need to use. And that one variable that we would need to figure out is that variable A. So what we're going to do is we're going to use that information to set up a new equation that we're going to be able to solve. So all I'm doing is I'm taking this middle term out of the picture for a second. It's really still there, but I can't solve multiple variables at the same time. That's much later on. So here's that new equation we're looking at. A divided by the sine of 24.3 degrees is equal to 2.68 divided by the sine of 54.6. And all we're doing here is we're solving for A. There's lots of different ways you can do this. You can cross multiply. Since you know that this is just a number, we can multiply both sides by the sine of 24.3 degrees. However you want to do it is completely up to you, as long as you know how to solve for our variable A. So what I'm going to do to solve for A, just to help me stay organized all the time, is I'm going to cross multiply real quick. Cross multiplication is going to get me 2.68 times the sine of 24.3 degrees equals my side A times the sine of 54.6 degrees. Now, in order to be able to figure out what A is, I need to get A by itself, and I'm going to do that by dividing both sides by the sine of 54.6 degrees. So over here, I'm going to divide this by the sine of 54.6 degrees. What that does is over here, the sine of 54.6, these ideas right here cancel each other out and make 1. And notice what I'm left with. I'm left with a little equation right here that says A equals, and that value on the left, it's not pretty, but it's a value that we can just plug into our calculator. And that's exactly what we're going to do. In my calculator, I'm just going to type that value. We're going to type in our numerator, 2.68 times, we can press times, but we don't have to. We can just type in sine of 24.3. Now, this is a point of interest. Remember, 24.3 is degrees. Now is the time where we click that mode button and make sure my calculator is in degree mode. Because if it wasn't in degrees, we're inputting something different and we might get incorrect answers. So now that it's in degree mode, I've got 2.68 times the sine of 24.3. That's my numerator. I'm going to hit enter. And then I'm going to divide that by the denominator, the sine of 54.6. When I hit enter, what I'm going to get is that is what A equals. A is equal to, give me 2 decimal places. So this whole fraction right here, A, is going to be equal to 1.35. So that's my value right here. A is equal to 1.35. This idea right there is nothing more than A is equal to 1.35. All right, so that's how we use the law of sines. Now, in this equation, in this example, we still have 2 pieces of information missing. We need to know side B and angle B. I'm going to leave that up to you to try and figure out those last 2 pieces of information. Hopefully, the first of those 2 that you find is angle B. Hopefully, you guys still remember something important about triangles that should help you be able to figure out angle B first. And once you know angle B, you're going to be able to set up ratios exactly the same way that we did for A in order to solve for that missing side B. So while you do that, press pause, give that a try, and then come back and let's look at example 2. So in example 2, it's going to be the same idea. We want to use the law of sines to find the missing information on a triangle. But notice this time they only give us one angle. They give us 2 sides, though. So again, when in doubt, sketch it out. Again, it's just a sketch. Does not have to be perfect. None of these angles are obtuse, so none of them are really 110 degrees. It's just the idea of, can I visually see what's happening? So later on, we know, do we use the law of sines, law of cosines, once we know both of those? I'm going to put the information on this diagram that it's given me. A is equal to 110 degrees. I know that side A, so across from it, is 125. Side B is 100. So again, label the things you know. Let's also make sure we put the things we don't know. We don't know angle B. We don't know angle C, and we don't know side C. So if we think again of our law of sines says A is to the sine of angle A, just like side B is to the sine of angle B, just like C is to the sine of angle C. We're able to fill in some information that we know. And the more we train ourselves to see some of these things, we're going to see, hey, here's where I have that ratio. I know both pieces of information here. I know side A is 125. I know angle A, so sine angle A is 110 degrees. And we want to be able to solve, the only place we're going to be able to solve is where we only have one variable. And that's going to occur right here with our B values. Because we know that our B value, side B is 100. This time, we don't know angle B, so we're going to leave that alone. So here's that equation we're going to be solved. Notice in this equation I have one variable, and that variable is B. Now, this is where something's a little bit different. I'm going to go back to the previous example, but notice right in here, I know there's a lot going on, but right in there, the only variable we had was A, but that was a side. The difference is in this, our angle that we're missing, B, right here, is embedded. It's part of that sine function. So we're going to have to be a little creative at the end when we're doing this. I like to do the same things all the time. 2 fractions with an equal sign in between. This is when we cross multiply. So here's what I'm going to get. I'm going to get 100 times the sine of 110 degrees is equal to 125 times the sine of b. When I do that, I'm going to want to get the sine of b. Before I can get b by itself, I have to get its term by itself. So I'm going to divide both sides by 125. And this is where I'm going to use my calculator to be able to get this information. So I'm going to do 100 times the sine of 110, my numerator. I'm going to do a quick double check to make sure I'm in degree mode, just to make sure. I'm going to hit enter. I'm going to divide that by 125. And what I'm going to get is I'm going to get this decimal, 0.7517, blah, blah, blah. I'm going to write that down as 0.751. 0.751 ... And the only reason I'm going to put that just so I can get that idea is my calculator stored it. I don't really need to know that. My calculator stored it. But again, think of what that is. 0.751 was this left side when I typed that in. The right side of my equation, 125's cancel each other out. So the right side of my equation is going to say this, the sine of b. I didn't want to know what the sine of b was. I wanted to know what did b equal. So this is where we got to think of, do we know a way that when we have an equation that says sine of b equals some value that we know how to figure out what b is? That's right, inverse functions. So the way we would use an inverse function would say that if we took the inverse of each side, it flips the input and the output. So what this would become is this, b is equal to the inverse sine of that number, 0.751, so on and so forth. And this is where my calculator's already got that number stored for me. It's now, once I hit enter, it's stored as the answer. So all I have to do is get to the sine inverse, which is second sine. That 0.751, I don't want to make it 0.751. I want to still use that. So I'm going to hit second and go down by the negative sign to get the answer. So now what my calculator is going to do, it's going to take the inverse sine of that previous number we have. I hit enter, and that is what b equals. Again, give me two decimal places. So we'll have 48.74. And this is what b is equal to. B is our angle, so I'm going to give it a label. We measure our angles in degrees. And now that I know angle B, hopefully we'd be able to go back and find angle C, since we'll know two of the angles. Once we know angle C, we'll be able to go back and find side C. So that's how we use the law of sines. The law of sines is used to help us find missing information. What I want you to do is, in this example, obviously you have to find angle C and then side C. And then I want you to give it a fresh start. Come to this triangle, example 3, and I want you to give it a try. Notice you know two angles. You should be able to easily find the third angle. And then I want you to use the law of sines to set up how are you going to solve for side A and side B. Once you do that, you know how to use the law of sines.